Okay, so we all use batteries every single day. I mean, how could we not, right?
Yeah,
But,
pretty much everything.
yeah, but I have to say, I don't think very often about like the science behind these little things that power all our devices.
Right.
So today we're going to go on a deep dive into a type of battery that maybe you haven't heard that much about before. Primary lithium metal batteries.
Yeah.
And we're going to be looking at a research paper to help guide us through this. It's called Primary Lithium Metal Batteries, Applications and Futures Development
Yeah.
by Jörg-Owe. And thankfully, we have an expert here to help us unpack it all.
Absolutely. Glad to be here.
So maybe to start us off, what makes these primary lithium metal batteries so interesting? What makes them different?
Yeah. So, well, first off, they're not rechargeable.
Yeah.
Like the lithium ion batteries you'd find in, say, your phone.
Right.
They're single use.
Gotcha.
And so they're designed for applications where you really need a long shelf life and high energy density. SnapPat actually points out that some of these batteries can last for like 10 to 15 years on a shelf.
Wow, that's a really long time.
It is, yeah. You know, it's like the marathon runner of the battery world. They just keep going and going.
I love that. So are there different types of these batteries?
Yeah, for sure.
Okay.
SnapPat actually outlines like 4 main types, and they each have their own kind of unique chemistry and ideal uses, I guess.
Okay, so break it down for me. Like, what are these different types?
Sure. So first up, you got lithium iron disulfide,
Okay.
LiFeS.
Okay.
These are known for their high energy density.
Okay.
You'll often find these in like, say, digital cameras.
Gotcha.
Things that need, you know, like quick bursts of power.
Okay.
And then you have lithium thionyl chloride,
Okay.
LiSoCl2.
Okay.
Now, these are really interesting. SnapPat actually highlights that these can withstand really extreme conditions.
Oh, wow.
Yeah. So, you know, things like military applications in harsh environments, maybe even like deep sea exploration.
Oh, so they're like the tough guy of the battery world.
Exactly. They can handle pretty much anything you throw at them.
I like that. So what about the other types?
So you also have lithium manganese dioxide,
Okay.
LiMNO2. And these are probably the ones you're most familiar with. They're, you know, found in everything from watches and sensors to those little coin cell batteries on computer motherboards.
Oh, yeah. Actually, I just replaced one of those in my smoke detector the other day.
Exactly. Yep.
It makes sense that they would use that type of battery for something like that.
Yeah. Long lasting and reliable.
Yeah, totally.
Yeah.
Okay, so what about the last type?
Last one is lithium sulfur dioxide,
Okay.
or LiSO2. SnapPat describes these as having a lot of power, but they often end up in kind of more niche applications because they can be more expensive,
Okay.
more complex to manufacture.
Gotcha. So it sounds like choosing the right primary lithium metal battery, it's really all about matching it to the right application, like what it's going to be used for.
Yeah, that's what SnapPat really drives home in this paper. You know, you really got to understand the conditions, like what the battery is going to be exposed to, how much power does it need, and then you can pick the best one.
Yeah, absolutely. Okay, so we've got a sense of the different types of these batteries, but where do we actually find them? Where are they being used out in the world?
Well, I mean, SnapPat actually lists a whole bunch of different applications. You know, they're in consumer electronics, like in our smartphones and laptops, but also in healthcare devices like glucose monitors and even pacemakers.
Pacemakers?
Yeah.
I never would have thought about that.
Yeah, I mean, think about it. They need a battery that's going to last a really long time and be incredibly reliable. You can't just easily replace a battery in a pacemaker.
Right.
So SnapPat really emphasizes how important that reliability and that longevity are, especially for healthcare applications. But we also see these batteries in military and defense equipment, even the Internet of Things, which is just exploding right now.
It's like they're everywhere.
They really are, yeah.
So what makes them so desirable? What are their big advantages?
Well, I mean, we've already touched on one of the major ones, the incredible shelf life.
Right.
But SnapPat also highlights their high energy density. You know,
Okay.
They can pack a lot of power into a small package.
So from a consumer's perspective, that probably means like our devices can last longer on a single charge, right?
Exactly. Yeah, exactly. And remember that low self-discharge rate we talked about?
Yeah.
Well, that means that even if a device is sitting on a shelf for, you know, a year, the battery's still going to retain most of its charge.
Wow, that's really incredible.
Yeah.
Are there any other advantages worth mentioning?
Yeah, for sure. SnapPat also talks about their ability to operate in extreme temperatures. So, you know, whether it's freezing cold or scorching hot, these batteries can handle it. So that makes them perfect for outdoor applications or even space exploration.
Oh, wow. Okay, it's amazing what these little batteries can do.
Yeah.
But are there any drawbacks to using them? I mean, are they perfect?
Well, of course, like with any technology, there are some limitations, and Snephat does address a few of those in his paper.
Okay.
But, researchers are always working on ways to improve things, and I think that's one of the most exciting things about this field. There's always something new happening.
Okay, so let's unpack some of those limitations then.
Yeah.
What are some of the hurdles with primary lithium metal batteries?
Well, I think the biggest one that Snephat really emphasizes is safety.
Okay.
These batteries contain a lot of energy, and if they're not handled properly or if there's a manufacturing defect, there's always a risk of fire or explosion.
Oh, wow. That's pretty scary. So what's being done to address those safety concerns?
Well, first and foremost, Snephat really stresses the importance of rigorous testing, especially for applications where a battery failure could have really serious consequences. But he also talks about the development of protective circuits and features that can prevent things like overcharging or overheating.
So like building in safeguards to try to minimize those risks.
Exactly. Think of it like a safety net for these powerful little batteries.
Okay, that makes me feel a little bit better. What other limitations are there?
Well, Snephat points out that electrolyte failures can be a problem.
Okay.
Electrolytes are the liquid or gel inside the battery that allow ions to flow between the electrodes. That's how you get that electrical current.
Okay, so I'm picturing it kind of like a highway for the energy to travel on.
Yeah, I like that analogy.
So what happens if there's like a roadblock, so to speak?
Well, if that electrolyte fails, it can really impact the battery's performance and lifespan.
Okay.
It can even cause the battery to stop working altogether.
No.
Yeah. Snephat highlights that researchers are doing a lot of work to develop more stable electrolytes and better designs that can prevent things like leaks or damage.
So keep that energy highway clear and flowing smoothly.
Exactly. Now, another issue that Snephat brings up is dendrite formation.
Dendrite formation?
Yeah, dendrites. Imagine these tiny needle-like structures growing inside the battery.
Oh.
And they can actually pierce the separator between the electrodes.
Okay.
And that can cause a short circuit.
Ouch.
Yeah.
Not good. Not good at all. So what's being done to combat these tiny little troublemakers?
Well, Snephat notes that dendrite formation can really shorten a battery's life,
Right.
make it less efficient.
Okay.
Scientists are looking for new materials and designs that can actually prevent those dendrites from growing in the first place, which could really help to make these batteries last even longer.
Okay. So it sounds like researchers are really, working hard to overcome these limitations. It's an ongoing process.
It is, yeah. It's a really, really exciting field to be in right now. But there's one more challenge that I think is worth mentioning.
Okay. I'm all ears.
Even though these batteries are designed to be used once and then discarded, recycling them properly is still incredibly important.
Right.
It's about recovering those valuable materials, minimizing the environmental impact.
Yeah.
But as Snephat points out, there are some real hurdles when it comes to recycling.
Okay. What kinds of hurdles are we talking about?
Well, for one thing, the processes can be really complex and expensive.
Right.
And some of the materials in these batteries can be hazardous and have to be handled very carefully.
Makes sense.
So researchers are still trying to develop better technologies, more efficient and cost-effective ways to recycle these batteries. It's not as simple as just tossing them in your recycling bin, unfortunately.
Yeah. It's a bit of a puzzle that needs to be solved.
It is, yeah. And there are still some knowledge gaps that need to be filled, too. For example, we need to better understand the long-term effects of different recycling methods.
Okay.
What works best and what's safest for the environment. Snephat argues that figuring out how to make the entire life cycle of these batteries more sustainable, well, that's absolutely vital.
Yeah, that makes a lot of sense. It sounds like there's still a lot to learn about these batteries.
Oh, absolutely, yeah. But that's what makes it so fascinating, right? There's so much potential for new discoveries and innovations.
Absolutely. So speaking of innovation, what about the latest research? What's on the horizon for primary lithium metal batteries?
Well, one of the most promising areas that Snephat highlights is the development of solid-state batteries.
Okay.
Now, these are a bit different because they use a solid electrolyte instead of a liquid or a gel.
Ooh, now this is where things get interesting. So what's so special about using a solid electrolyte?
Well, for one thing, it makes the batteries much safer
Okay.
and more stable,
Uh,
and they could potentially store even more energy than our current designs.
wow. So does that mean we won't have to worry about leaky electrolytes anymore?
That's the idea. And because these solid electrolytes aren't as prone to dendrite formation, these batteries could potentially last even longer.
Oh, it's great.
Yeah. And Schneepat specifically highlights their potential for use in high-stakes fields like aerospace and medical devices.
Okay.
Places where reliability is absolutely crucial.
Yeah, that makes a lot of sense. It sounds like solid-state batteries could be a real game changer.
They really could be, yeah.
So what other innovations are being explored?
Well, there's a lot of work being done on developing new recycling technologies.
Right.
Trying to make them more environmentally friendly, more cost-effective. Scientists are experimenting with different methods to recover valuable materials from spent batteries so that we don't have to keep mining new resources.
So it's like turning battery trash into treasure.
Exactly. And of course, there's always the focus on improving safety. Researchers are working on new designs, incorporating safety mechanisms to prevent overheating, short circuits, and other potential hazards.
Okay, so it sounds like they're really trying to make these batteries as safe as possible.
They are, yeah. And it's not just about safety either. There's a lot of research aimed at boosting performance and efficiency, like finding new materials and designs to increase energy density, extend battery life, and improve the overall functionality.
So it's like they're constantly trying to fine-tune these batteries to make them the best they can be.
Exactly. Yeah, it's a really dynamic field, always innovating, always pushing the limits.
This has been fascinating. It's amazing to learn how much science and engineering goes into these tiny little things that we take for granted.
Yeah, it's pretty incredible.
Before we move on, what was the most surprising thing you learned from Schneepat's paper?
Honestly, just the sheer range of applications for these batteries. It really highlights how important they are in so many different aspects of our lives, from our everyday gadgets to, highly specialized equipment. I think it's easy to forget just how much we rely on them.
That's a great point. I was really intrigued by the potential of those solid-state batteries.
Yeah.
It feels like that technology could really change how we power things in the future.
Oh, absolutely. I think the possibilities are really exciting. Now, before we wrap up this part, I want to leave our listeners with something to think about.
Okay.
Given everything we've learned about primary lithium metal batteries, both their limitations and their potential, how do you think this technology should be developed in the future? What areas of research do you find most interesting? What are the ethical considerations?
Those are some great questions for our listeners to ponder. The future of battery technology is something we're all going to be a part of, and it's up to all of us to make sure that its development is responsible and sustainable.
I couldn't agree more.
We'll be continuing our deep dive into the future of primary lithium metal batteries in Part 2, where we'll explore some of those broader questions and delve deeper into the innovations that are shaping the field.
Sounds good. Looking forward to it.
But until then, we encourage you to explore the world of batteries on your own. Maybe something Schneepat said in his paper piqued your interest. Do some research, dig a little deeper, and see where your curiosity takes you.
It's a fascinating world to explore, that's for sure. And the more we understand about battery technology, the better equipped we'll be to make informed decisions about its development and its use.
Well said.
Yeah.
So until next time, keep those electrons flowing and those batteries charged.
So welcome back to our deep dive into primary lithium metal batteries. Last time, we talked about the different types, their uses, what they're good at, but also some of the challenges. And, when you look at Jörg-Owe Schneepat's research, he really focuses on the future. Like, how are we going to overcome these things? How's this technology going to evolve? And innovation, that's really the key.
Yeah, I'm really curious to hear more about what Schneepat envisions for the future.
Mm-hmm.
Last time we briefly touched on solid-state batteries.
Yeah.
And that sounded really, really promising.
Yeah, definitely. And Schneepat, he's quite optimistic about those, especially when you think about things like electric vehicles or storing energy from renewable sources.
Oh, okay. So those solid-state batteries, they could be a big part of moving us towards a cleaner energy future.
That's the idea, yeah. And it's not just about the technology itself. Schneepat, he really emphasizes how important recycling and sustainability are going to be in the future of these batteries.
Right, because we talk about some of the challenges with recycling these batteries. So finding solutions in that area, it's not just good for the environment, it's good for the economy as well, right?
Exactly. He actually uses the term circular economy, this idea of, we recover those materials, we reuse them, we minimize waste, and we become less reliant on having to mine new resources.
So like your old phone battery could be used to build a new one. That's a pretty cool concept.
It is. And he also talks about how the industry is starting to look at alternative materials to use in these batteries.
Okay, so why move away from traditional lithium?
Well, a couple of reasons. There's this concern about, disruptions to the supply chain.
Okay.
Lithium is a finite resource. It's not unlimited. And the price can go up and down depending on global demand.
So you don't want to put all your eggs in one basket, right?
Exactly, yeah. And the other reason is, the environmental impact of lithium mining.
Oh, right.
It can be very energy intensive, and sometimes there are negative effects on the ecosystems around those mines.
Okay. So, if we can find these alternative materials, that could make battery production more sustainable over time.
That's the goal, yeah. Schnepphat also talks about the role that these batteries are going to play in the Internet of Things. And we all know that's just growing exponentially.
Yeah, I mean, we talked about how these batteries, they're perfect for powering those tiny sensors and devices, that are popping up everywhere.
Yeah, and as the Internet of Things keeps expanding, well, we're going to need more and more of these batteries.
It's almost like every device is going to need its own little heartbeat, powered by a primary battery.
I like that analogy. And then finally, Schnepphat looks at how these batteries could be used to store energy from renewable sources. And I think that's something that a lot of people are interested in.
Yeah, absolutely. I mean, how could these batteries affect our daily lives, in a future where we're using more renewable energy?
Well, think about it. Let's say you have solar panels on your roof.
Okay.
They're generating electricity all day long, but what happens when the sun goes down?
Well, you need somewhere to put that energy so you can use it later.
Exactly. And that's where these batteries come in. They could be used to store that energy for homes, for businesses, even whole communities.
So it's like having your own little energy reserve.
Exactly. And that gives you more control, more independence, and it all ties into Schnepphat's vision of a more sustainable energy future, one that's more resilient too.
So it sounds like the future of these batteries is incredibly bright. They can power everything from our devices to, how we generate and store energy on a much larger scale.
It's definitely a field full of potential and possibilities. And as research continues, who knows what amazing discoveries are just around the corner.
It's exciting to think about. This has been a really incredible look at the world of primary lithium metal batteries. We've talked about the different types, all the cool applications, what they're good at, the hurdles they face, and we've also looked ahead to the future, thanks to Schnepphat's research and the innovations that are happening.
It's been a pleasure exploring this topic with you. Schnepphat's paper really does provide a wealth of information.
Before we wrap up this part, I'm curious, what stood out to you the most from Schnepphat's work? What were your biggest takeaways?
I was really struck by how much Schnepphat emphasized safety.
Okay.
And sustainability. These have to be top priorities as we develop and use these batteries. It can't just be about how well they perform. We have to be responsible.
That's a really good point. For me, it was just how versatile these batteries are. They're powering medical devices that are literally saving lives. Mm-hmm. And then they're also powering those tiny sensors that are connecting our world in these incredible ways.
Yeah, it's true. They're everywhere, and their impact is just going to keep growing in the coming years. Now, before we move on to part 3, I want to leave our listeners with one final thought. Given everything we've learned from Schnepphat, what role do you see primary lithium metal batteries playing in your own life in the future? Will you look at your devices differently now that you know more about what's inside them? Will you think more about recycling your old batteries? It's a good question for everyone to consider. The choices we make today are really going to shape the future of this technology and how it impacts the world.
Those are some great points to ponder as we move into part 3 of our deep dive into the world of primary lithium metal batteries. We'll be back to answer some listener questions and explore some of the broader, ethical and environmental considerations surrounding this fascinating technology.
Looking forward to it.
Until then, keep those batteries charged and stay curious. Welcome back to the deep dive. We've been talking all about primary lithium metal batteries for the last 2 parts. I think I'm using this awesome research paper by Jörg-Owe Schnepphat as our guide.
It's been a fun journey.
Yeah. We've talked about the different types, what they're good at, what their limitations are. And, what's so cool is kind of looking ahead, thinking about the future of this technology.
The future is definitely bright for batteries.
It is. And today, as promised, we're going to answer some of your questions. You guys always come up with the most thought-provoking stuff.
Yeah, can't wait to dive into these.
Okay, so our first question comes from Sarah in Seattle. And Sarah asks, you mentioned that lithium mining can be bad for the environment. Are there any efforts to make that process more sustainable? What do you think?
Yeah, that's a really important question, Sarah. And actually, this is something that Schnepphat talks about in his paper. I mean, people are becoming more aware of, the impact of lithium mining, both on the environment and on communities. And so there are definitely some promising things happening.
So, what kind of initiatives are being developed?
Well, some companies are looking at ways to extract lithium from these brine sources, but using more sustainable methods, things that use less water and have less of an impact on the ecosystems around them.
Okay.
Schnepphat actually mentions some research that's being done on what's called direct lithium extraction, or DLE. And basically, these technologies are aiming to pull lithium from brines and clays, but in a much more efficient way, and one that's gentler on the environment.
So it's like they're trying to figure out how to get the lithium we need,
Yeah.
but without, leaving this huge footprint behind.
Exactly. And then, of course, there's all the work being done on recycling. The more lithium we can recover from those used batteries, well, the less we have to mine in the first place.
Right. It's all about closing that loop, making the whole cycle more sustainable.
Absolutely. Okay, so our next question comes from John in London. And John asks, what are the ethical considerations surrounding primary lithium metal batteries?
Oh, that's a great question, John. It's so easy to get caught up in, all the cool new technology.
Right.
But we have to remember the bigger picture.
And Schnepphat, he actually does highlight some key ethical points in his research. And, one of them is responsible sourcing. We need to make sure that the lithium that's being used in these batteries, that it's not coming from, mines that have bad labor practices or that are harming communities.
So it's kind of like, how we're more aware now of where our food comes from or our clothes are made.
Exactly. Transparency, accountability, all of that. Another thing is, how do we get rid of these batteries once they're no longer useful?
Right, because we've talked about how important recycling is.
And it needs to be done safely. We don't want to create new problems while trying to solve old ones, right?
Yeah, we can't just throw our old batteries in the trash and hope for the best.
Exactly. We have to support responsible recycling. And then I think another ethical consideration that Schnepphat touches on is, access and equity. As we develop these new technologies, we have to make sure that everyone benefits, not just a select few.
That's such an important point. Clean, affordable energy. It shouldn't be a luxury. It should be a right.
Absolutely. We want everyone to be a part of the transition to a cleaner, more sustainable future.
Wow. These listener questions have really brought up some important things to think about. It's clear that the future of batteries, it's not just about, the science and the engineering. We have to factor in the ethics and the environment as well.
I completely agree. It's about progress, but it has to be responsible progress.
Absolutely. Well, that brings us to the end of our deep dive into the world of primary lithium metal batteries. We learned about the different types, what they're used for, the challenges they face. We even got to ponder some of the ethical questions surrounding this technology. It's been quite a journey.
It really has. And, it feels like we're really just at the beginning. There's so much more to discover.
And who knows, maybe one of our listeners will be the one to make that next big breakthrough.
I love that thought. Or maybe, someone was inspired to learn more about batteries, maybe even think about a career in this field, or just be more mindful about how they use and dispose of batteries in their everyday life.
Every little bit helps. Well, thank you so much for joining us on this deep dive into the world of primary lithium metal batteries. We hope you enjoyed it. Until next time, keep those batteries charged and those minds curious.